the board. Let's get quickly, let's start with warm up and then we got to make progress. So, go ahead, tell me. That one, not this one. How would I convert ethyl benzene into 3-phenyl propanoic acid or 2-phenyl ethanoic acid? Anybody?
Step 1 is NBS.
Okay, for which one?
The
Top down?
the second lower one.
This one?
Yeah.
Okay, so if you do NBS, what are we doing? We are basically putting a bromine in the benzylic position. Is that what you're trying to do? Okay, if you do NBS, don't forget heat or light.
Okay.
Without heat or light, NBS is not going to do much. So NBS with heat or light. Okay, what next? So you put a bromine on that position. Then what? So now we have this. Okay.
Potassium T-butyl oxide
Okay, and what's the purpose for that?
to give us a Hoffman
Hoffman
alkene.
There's only one product possible.
Yep.
There is no other place where it could go, right?
Mm-hmm.
So the point is you want to do E2 to make phenylethene, also known as styrene. So does it matter what the size of the base is? Is there Hoffman or ZF, anything like that in this case?
No.
There isn't, right? So you can either use a bulky base, absolutely, there's nothing wrong with that but if you didn't use bulky also, you would get the same product. Agreed?
Mm-hmm.
Okay, what then? Don't forget heat because it's E2. You need to heat when you want to do E2 reaction. Okay, what's next? You want to put a BR there? No. So you saying you want to convert this into this?
Yeah.
Is that what you're saying? Okay. What's the next step after that? Can be sure, but where is that taking us?
Fourth step would be NaCN.
Okay, so now you got to pause. Because again, you could go different places from here. So if that's where you're going, count your carbons, guys. How many carbons in the reactant?
Two. There are two on the branch.
Okay, 2 on the branch, total 8.
Yep.
How about the product?
9.
Ooh, careful, count
Right.
properly, unless I made a mistake.
Same.
So did we add any carbons?
No, we
So
didn't.
if I say I did converted this into nitrile and then hydrolyzed it, wouldn't I be adding a carbon?
Yeah, you'd be adding a carbon.
So that's why I meant, okay, I
No,
want
no
to see where you're
sodium
taking that.
cyanide. Yes,
So we need to figure out a way to convert this alkene into the carboxylic acid without changing carbons. Yes?
Would you first go from alkene to an alcohol?
Okay, so what do you want to use?
We could use.
Do you want Markovnikov's alcohol or anti-Markovnikov alcohol?
Anti-Markovnikov.
Because you want to put an OH here. Primary alcohol, right?
Okay,
Yep.
okay.
So you want to do anti-Mark. So what is the reagent for that?
B2, B2H6.
B2H6 or BH3.
Mm-hmm.
And then what is that followed by?
Base.
You need an oxidizing agent, hydrogen peroxide, in presence of a base, of
Yep.
course, but you need oxidizing agent. Okay, so that makes this is the anti-Markovnikov hydration of the alkene. You get that alcohol, then what?
Na2Cr2O7, H2SO4.
Since this is a primary alcohol, you can use a strong oxidizing agent such as sodium dichromate in an acid, converts primary alcohol into carboxylic acid. But do you guys, I think the important thing I wanted to emphasize here is count your carbons.
Mm-hmm.
From this to the product, carbons is the same. So we cannot add carbons or take away carbons. You got to make sure you're counting for that. Make sense, everybody?
Yep.
But then what if the first one, again, you have 8 carbons there, but how many carbons here? So we added a carbon here.
Okay.
So you got to now process it and say, okay, we are adding a carbon to make a carboxylic acid. So how?
First do NBS.
Okay, So we are still putting a leaving
Heat.
group on the NBS with heat or light. Please don't ignore the heat or light.
Mhm.
But you're putting a leaving group, you're getting a leaving group on the benzylic position. Okay, then what?
KOT-butyl.
Sure, or the size again of the base is not important because there is only one product you can get with the elimination. So whether it's bulky base or not bulky base, both of them are going to give us the same. Agreed?
Yep.
Okay, then what?
Um,
So now it makes sense to put a leaving group on that terminal position. So we are adding HBr, but in presence of peroxide, so you get the anti-Markovnikov hydrobromination, okay? And then,
we're adding a carbon, so we would use cyanide.
okay, you can do an SN2 reaction with sodium cyanide, potassium cyanide, so it gives you the nitrile, the cyano product. What next?
And then H3O plus with heat.
Hydrolyzing that with heat converts the nitrile into one extra carbon, right? Is
Yep.
there something else we could do after you put a bromine on that carbon atom? Is there something else we could do instead of this?
Grignards?
Oh, exactly, we could also go Grignard route. Because once you get the bromine, we could have converted that into Grignard by reacting it with magnesium. And then how do you bring in the extra carbon? Where's that extra carbon going to come from that will react with Grignard, which is also the lab tomorrow?
CH3.
Carbon
CO2.
dioxide.
CO2, okay.
Both of these are adding a carbon. Both of these methods are adding a
CO2,
carbon,
okay.
and then of course, when you
We
hydrolyze
use
that,
H3O plus again.
that's what we are doing in lab tomorrow, is we are carboxylating a Grignard. We are basically having Grignard react with carbon dioxide. The point I wanted to make with these two examples is, guys, there are ways of creating carboxylic acids without changing the number of carbon atoms, but then these two methods will always increase the carbon by 1. Do you all see that?
Mm-hmm.
Okay, cool. So let's summarize the syntheses of carboxylic acids that we saw so far. We know that carboxylic acids can be made from primary alcohols by using, I'm not writing everything here, I'm going to let you guys fill it up, by using a strong oxidizing agent. Primary alcohols can become a carboxylic acid. We also know that aldehydes will become a carboxylic acid using a strong oxidizing agent. Again, we also know that primary alcohols can become aldehydes by using PCC. We've already seen that. We've also seen that alkynes, ozonolysis can give us carboxylic acids. And then, benzene alkyl side chains with a strong oxidizing agent. I'm not filling it all up. I'll let you guys do that because we've done it already. Except, please do not forget to make a note, except when R is a tert butyl group. Tert butyl does not react with those. And then we saw 2 new ways of making carboxylic acids, both of which add 1 carbon atom each. One is reacting with RMGX with carbon dioxide followed by acid workup, adds a carbon from the carbon dioxide, and the other is from a nitrile, which also can be hydrolyzed, or we can also hydrolyze it with a base. We'll look at those mechanisms later, but then you have to acidify it. And where do both of these come from?
RNGX comes with reacting an alkyl halide with magnesium.
Alkyl halide. Exactly, both of these come from alkyl halides. Alkyl halides come from where? Isn't that right, everybody?
Mm-hmm.
Yeah, let's look at a summary of their reactions of carboxylic acids. What are the different things they can be used for? Mark, could you do me a favor?
Oh, yes.
Thank you. Now, by the way, chapters 20 and 21 kind of go hand in hand. That's why I've put both of them in one module, because the way I look at them, it's really one big chapter, acids and acid derivatives. So FYI, in case you don't find something in chapter 20, it might be in chapter 21, because I'm mixing it all up. Okay, so couple of reactions of carboxylic acids. One that we've already seen, we've seen it several times, even in the, one that we've seen several times. Do carboxylic acids react with Grignards?
Yeah.
And how much Grignard?
Excess.
You need at least 2
plus.
or more, exactly, equivalent of Grignard. We've done the mechanism, we've written all of that stuff for this reaction. What's the product? Anybody?
And
What's the product? Sorry. When a carboxylic acid reacts with excess Grignard, what's the product? No,
a ketone.
not with carboxylic acids. Aldehydes, ketones, yes, you get an alcohol. With this, you get a ketone. And the mechanism we've written several times. So guys, you guys really do need to know the mechanisms, because we have written those several times. This reaction does not give us an alcohol. It actually cannot give. If you follow the mechanism, there's no way it can give us an alcohol. It gives us a ketone. Okay, so that, again, mechanism you got to know for this one. Well, we kind of have to know the mechanism for that. That one we haven't written it yet. We'll write it later. Another reaction of carboxylic acids is reduction. These can be reduced. Could I just write it this way so we can start making connections to a primary alcohol? The carbon of the carboxylic acid is the same as the carbon of the primary alcohol. So by reducing the carboxylic acid, we can create the primary alcohol back. And this is done by using lithium aluminum hydride. Strong reducing agent can be used to reduce the carboxylic acid back into the primary alcohol. Bless you. There is one other reagent that can also do the same thing, and that is something you've seen for a different purpose, but that is using BH3 in water, I think. Will also convert, or maybe TH, sorry, my mistake. Let's just say BH3. Can also convert a carboxylic acid into a primary alcohol. Okay?
Okay.
Everybody okay so far? The rest of the reactions of carboxylic acid that I'm going to write them in a very general sense, because we will look at each one at a time a bit later down the chapter. We won't look at them in detail right now. I'm just listing them there. What does the word derivative mean to you?
Come from.
It comes from.
Comes from. The acid derivatives come from carboxylic acid and can go back into the carboxylic acids. The carboxylic acid derivatives are as follows. Could you please, sorry?
Yeah,
I'm so sorry. Are as follows. Oh, thank you, that's even better. Thank you so much. Acid halides, okay, fine. Those are carboxylic acid derivatives, because the carboxylic acid can become this, but this can also go back, as we'll start looking at the details one at a time. And the mechanisms are almost the same in terms of the general features. Then comes acid anhydrides. Then come esters. Oops, sorry. That's not an ester. It's a ketone. And finally, amides. Primary, secondary, tertiary, whatever. The point is amides. There's also nitrile, of course, because nitriles can be used to convert into there, but there's another way of making them. We'll get to it a bit later. So the point is, acid can become the derivative, and the derivative can be hydrolyzed back to the acid. So these we will look at their mechanisms and the details one at a time a bit later. But there's that one other interesting thing about these derivatives families. Of the 4 families of acid derivatives, the acid halides are most reactive. These are the least reactive. So the reactivity of the 4 categories of acid derivatives is in that order. Amides are least reactive. Acid halides are the most reactive. Of these 4 I'm talking about, these 4 categories. Why am I bringing that up? Because as we'll see as we go forward, I'm only talking about these 4 right now. Each of these families can be converted into other family that is less reactive than itself, but not the other way around. Does that make sense?
Mm-hmm.
Each of these families can be converted into another of those that is less reactive than itself. The more reactive can become less reactive, but not the other way around. Good? What does that mean? It means that, what color? Where? There you go. I don't like the green part. Have another one. Which means this is the most reactive of the 4, which means this can be converted into that, it can be converted into this, it can be converted into this as well, but not opposite. Everybody okay?
Mm-hmm.
What about the acid anhydrides? Can acid anhydrides go to acid halides?
No.
No. But can the acid anhydrides go to esters?
Yep.
Yes.
Can the acid anhydrides go to amides?
Yep.
Yeah.
Absolutely. What about esters? Can esters go upwards?
No.
No.
But can the ester go downwards?
Yep.
What about amides? Can amides be used to make any of those?
No.
Because they are the least reactive. That's the most reactive family of the 4 derivatives. That's basically what it means. And when we start looking at their mechanisms and all, you will see they're pretty much doing exactly the same thing. And the mechanisms become very repetitious as we start looking at each of them. But those are the acid derivatives. Questions?
For the amides, primary, secondary, tertiary, and that's
I'm putting them all together. But yes, amides can be primary, secondary, tertiary, because it's a combination of carboxylic acid and an amine. And amines can be primary, secondary, or tertiary.
Mm-hmm.
Sounds okay, everybody?
Mm-hmm.
Cool. So let's start looking at the derivatives of acid, carboxylic acids, meaning all of these different families. And along the lines, we will of course talk about mechanisms and all. I gave you guys these handouts last week. Did you get one? No, you want to take it?
I have one,
Please.
but it's deep in my paper someplace.
So let's fish it out because we didn't go over all the information on the handout. So we'll start with naming each of these categories of compounds, which can get tricky unless you stay organized. And then we'll talk about syntheses and reactions and mechanisms and all of that stuff. So first we'll start with nomenclature of the acid derivatives. The first page on that handout is basically giving us the rules. Instead of writing all of that, because it gets tedious, I just made a handout. Now, what I always do when I'm trying to name these families of compounds is I start with the name of the parent carboxylic acid. With the name of the parent carboxylic acid, then I make the changes necessary to name the compound in front of us. So what do I mean by that? First of all, please understand, when we are looking at acid halides or acid anhydrides or esters or amides, again, primary, secondary, tertiary, whatever, and nitriles. We will also learn to name nitriles. This portion comes from the carboxylic acid. This portion that I'm circling is the parent carboxylic acid. This portion, which may or may not be the same as the other, it may be symmetrical or unsymmetrical anhydride. These two may be the same or not be the same. This portion for the ester, this portion for the amide, and this portion for the nitrile. Those are coming from carboxylic acid. So when I name these families of compounds, except nitrile is different, so I'll get to that later. But for the other four classic acid derivative families, personally, I always start with the name of the parent acid. And then I modify that to become the name of the compound. So, for example, the handout tells you, let's say I'm trying to name the acid halide. So, how do we name the carboxylic acid? As we've already seen, alkanoic acid. Isn't that right?
Alkanoic acid, yep.
That's the parent. So whatever the parent is, we'll write its name and then make the changes. What are the changes for the name of the acid to become the name of the acid halide?
Alkyl halide.
That's alkyl halide. This is acid halide. It can't be. What
That's
does it say? What
what
to
it's-
change? Guys, you all have
Oh,
this.
alkenyl halide.
You all have this on the handout.
Oh,
First page of the handout gives you all of these rules, so you don't have to write them. Instead, you spend time on understanding them.
alkenyl.
You all
halide.
have it.
Yep.
Okay. So yes, the only thing we are doing is we are taking the ic, replacing it with YL, and acid is being replaced by the halide.
Alkenyl halide.
Alkanoyl.
Alkanoid.
There's an O there. Alkanoyl halide. So alkanoic acid becomes alkanoyl halide. Do you all see that?
Mm-hmm.
Okay. When it comes to the anhydride, once again, whatever the alkanoic part is, alkanoic acid, all we do is take away the acid and put the word anhydride in its place. So it becomes alkanoic acid. But that's for symmetrical anhydride. When this portion is the same as that portion, then that works. But if this portion is not the same as the other one, so this is for symmetrical one, but if the two acids are not the same, then we have alkanoic anhydride, and these are in alphabetical order. So symmetrical anhydrides are simply alkanoic anhydride done. Unsymmetrical anhydrides, you've got to specify both acid parts in alphabetical order, followed by a third word, anhydride. Everybody okay?
Yep.
Now in esters is considered as a combination of carboxylic acid and alcohol. So esters are made biochemically. How are esters made? Well, carboxylic acid plus alcohol gives us ester. We'll look at that a bit later. But the point is, how do we name it? You start with the alcohol portion first. Start with the alcohol portion, alkyl. That's just whatever the R is alkyl. Okay. As a separate word. So there are two separate words here. Now we addressed the acid part. So whatever the acid was supposed to be. What are we changing for the acid part?
We are changing the ic acid to alkanoate.
So we are taking that away and adding the ATE, alkanoate. So it's a two-word name. Alkyl, the alcohol portion alkyl, followed by the acid alkanoate. Everybody okay?
Uh-huh.
What about the amides? Now amides, as you said, can be primary, secondary, tertiary. So let's look at it one at a time. If you have a primary amide, meaning the nitrogen has only hydrogens and no R on the nitrogen. Secondary amides, where the nitrogen has one R, and tertiary amides. No hydrogen or nitrogen, just the R's. So, once again, the acid portion is this. This is the part that's coming from the carboxylic acid. So, let's start with the primary amide. If the name of the parent acid is alkanoic acid, what parts are we changing here?
Taking out the oic acid for amide.
So the oic acid is gone and it's replaced with, so primary amide is an alkanine, you got it. It's one word.
Alkanamide.
Alkanamide, perfect.
Alkanamide.
Secondary, tertiary, you got to pause because you have to indicate in your name that there is an R on the nitrogen. You have to indicate that this R is on the nitrogen. And similarly for tertiary, this is secondary, this is tertiary amide, you have to do that same thing. So how do we indicate that a certain thing is on the nitrogen, not carbon 1 or carbon 3 or carbon 6 of the parent, but this is on the nitrogen? That's when we use uppercase N. I don't know if you remember this or not. I think first quarter and all, there were some right in your lab notebooks and other places, I would cross out and correct it because some of you would write uppercase N and I'm like, no, that, and of course we hadn't done this at that time, so I didn't explain what was going on, I would just correct it. Uppercase N indicates nitrogen. So if the alkyl is on nitrogen, you are basically saying N-alkyl, meaning that alkyl is on the nitrogen. So that N has to be uppercase N. And the rest. Alkanoic acid. Once again, you take away the, you're right. Take this away and replace it with. So what do you think we would do here?
N dialkylamide.
If these two are the same, if R prime and R double prime are the same, then yes, you can do just like you would give positions of everything, you would give positions of both R's, and since there are two of them, dialkyl alkanamide. But what if the R's are different? If these are different?
N-alkyl and alkanamide.
In alphabetical order, like we always do. Then you do it in alphabetical order. And we'll do examples of all of them. Sounds okay, everybody? When it comes to nitriles, these are the simpler ones to name in a way, because whatever is the alkane representing those many carbon atoms, we just use that with the E followed by a suffix nitrile. Alkane, nitrile, whatever the R is, carbon number 1 is that. That's where the counting starts. But that's IUPAC. Unfortunately for nitriles, a lot of common names are out there in use, acetonitrile, benzonitrile, which is obviously not an IUPAC naming system. So unfortunately, there are a lot of common names for nitriles in use. So for common names, which is very, for nitriles, it's actually starting with the common name of the carboxylic acid. So it's really non-alkanoic acid, but I'll just use it as a reference point. So we are taking this benzonitrile. Yep. Taking the ic away and the acid away, and just attaching a suffix nitrile to that. That's why acetic acid becomes acetonitrile, benzoic acid becomes benzonitrile, so on and so forth. So those are really coming not from the IUPAC name of the carboxylic acids, but their own common names. You're modifying them accordingly. So the rules are all written here. Let's apply them, right? Page 8. How does 2 and then 8? By the way, don't go by numbering. They were in my notes. My pages in my notes are numbered, so that's why the numbers are like, oh, who cares? But let's start from the third page and let's look at some and see. This is the one I'm using.
It's on camera.
I don't remember. Okay, let's start with naming these guys. So, you don't have to draw them because you have them in front of you, but I will draw them. So what category is this first compound? Which category of compounds does that belong to?
Esters.
Do you all agree?
Yes.
Okay, so when it comes to esters, which part is named first? The carboxylic acid part or the alcohol part? Alcohol part. Which
alcohol
part is
part.
the alcohol part?
The ethoxy.
Sorry, you're right, but it's not an ethoxy group. You're just looking at this R.
Mm-hmm.
What is that R called?
Ethyl.
So that's what we start with. Now let's focus on the carboxylic acid. The rest is carboxylic acid. So what would we call that carboxylic acid? If this were a carboxylic acid, what would be its name?
Ethanoic acid.
No. Count your carbons.
Propanoic acid.
Do you all agree? Propanoic acid. So how do we change the name of the acid portion to reflect the ester?
Instead of ic
Propanoate.
acid,
Take that away and then delete. So this compound is ethyl propanoate. Once again, the ethyl is the alcohol portion R. The propanoate is the carboxylic acid portion. You guys see that?
Mm-hmm.
Okay, next one. What is that? Is that what family is this?
An amide.
Oh, actually, I was going vertical. Sorry.
Oh, sorry. Acid halide.
Okay. So if it's an acid halide, let's first figure out the name of the carboxylic acid. This portion is coming from the carboxylic acid. So what would we call it?
Cyclopentyl.
Cyclopentane,
Cyclopentane. Cyclopentane.
Carbonyl.
Carbonyl chloride.
Oh, yeah.
What's the name of the carboxylic acid?
Cyclopentane carboxylic acid.
Exactly. Cyclopentane carboxylic acid. Is that right?
Yes.
Yep.
Now we need to change this name to reflect the acid halide. So which parts are we going, what are we going to change here?
The oxalic acid to an
Chloride.
NyL chloride.
So these ones are a little tricky because I don't know if I wrote these in the name. Did I write these in the
Yeah.
rules?
Yeah,
Did I-
cycloalkane carbonyl halide.
Oh, I did write that. Okay, yeah. So then you are taking that whole thing away. This is becoming, and then what's happening to the word acid?
It's carbonyl, it's chloride.
Cyclopentane carbonyl chloride. Once again, the cyclopentane carbonyl is coming from cyclopentane carboxylic acid, and the chloride is telling us what's the halogen on it. Are we okay, everybody?
Mhm.
Cool. What's the next one? Just going down the list. Oh, that's an ester too. Okay. What would you call it? So start with the alcohol portion. What is the alcohol portion called?
Tert-butyl.
Do you all agree?
Yes.
Okay. And then from the, what's the acid called?
The acid would be benzoic acid,
So
but it
then we change it now. So benzoic acid would become?
would benzenoate.
No. Benzoic acid would become?
Benzoate.
Exactly. Benzoate. That's T-butyl benzoate. Once again, they're two separate words. This is talking about the R on the single bonded oxygen. This is talking about the carboxylic acid that it came from. Everybody okay? Next one, that's a primary amide. So how would we name this primary amide? So first, let's start with the carboxylic acid, benzoic acid. Okay, so if the parent is benzoic acid, how do we change this to become the amide?
Benzamide.
The oic acid gone,
Yeah.
right? Exactly. Make sense?
Yes.
Okay. Do you guys want to give a try to the next one down the list? I'm going vertically. Why? I have no idea. Go ahead, give it a try because this is also an acid halide. Start with the name of the carboxylic acid. So what's the name of the carboxylic acid? Guys, can I erase this board?
Yeah.
While you are working on that one? Okay. So let's pretend that that's a carboxylic acid. Instead of the Br, there was OH. How would you name it? Yeah, but there's a lot of other
yeah.
things too, right? So the full name.
Free
So if this were a carboxylic acid, what would you call it?
Free hydroxy, formethoxy, pentanoic acid.
Do you all agree? 3-hydroxy because that's carbon 1, 2, 3. 4-methoxy. And then what did you say after that?
Pentanoic acid.
Pent and oic acid. Do you all agree?
Mm-hmm.
That's the name of the parent acid. Now let's transform this to become the name of the bromide. So what are the changes we would make? Again, front page, first page has all the steps. So what are the changes I'm going to make?
So it would be free hydroxy, formethoxy, pentyl.
What changes should I make, guys? It's on the
Pentyl
front
bromide.
page.
Oh, it's gonna be
Take the ick away. Is it oic or just the ick?
just the ick.
Ick.
Yeah.
And replace it with?
Alkenyl
And what do I do with
Pentyl.
acid?
halide bromide.
So that's the name of the compound given. It all comes from the acid though. Does that sound okay, everybody? So you gotta go step by step. You gotta go a little slow in the beginning till you start remembering. Okay, let's go to that amide. What are we gonna call it? Louder. N-diphenyl, good, because there are phenols on the nitrogen. So N, N diphenyl, okay. Perfect.
Propanamide.
Propanoic acid becomes propanamide. Do you guys agree?
Mm-hmm.
Now I have a curiosity question. I don't know if I have examples of those or not, but what if the amide were this? How would you name it?
Two phenyl, N-phenyl.
So why can't I just do 2, N diphenyl propane?
Okay.
Right? Because if you had methyls in different places, can't you do 2,5,6 trimethyl blah 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 blah? We can do the same here. The only thing though is to indicate that one of those phenols is on the nitrogen, you're using N, uppercase N, as the position number. To differentiate between the fact that one of the phenols is on carbon 2 of the chain, but the other phenol is on the nitrogen.
Mm-hmm.
Do you all see that, everybody?
2N-diphenyl
Everybody okay?
propanamide.
Okay, so what if the amide were how would we name this? Again, groups are in alphabetical order, that doesn't change. But how would we name this compound?
Two chloro.
So once again, the parent numbering starts from here, 2, 3, okay? So you're saying there's 2 chloro, okay?
And dimethyl.
Exactly. And then
Propanamide.
that doesn't change. Everybody okay? So are you seeing the difference between how to indicate that something is on the nitrogen versus something else is on the chain of the carboxylic acid? Carboxylic acid chain is numbered like we normally do. The groups on the nitrogen are indicated with N, uppercase N. Is everybody okay? Questions? Okay, where did my handout go? Oh, there it is. Okay, next one. What would we call this?
3-methyl pentanitrile.
So let's draw it out. 3-methyl pentane nitrile. So carbon 1 is this, right? So this is 3-methyl, and then pentane, because 5 total carbons, and followed by a suffix. Next one. Ooh,
We have
that's
an
interesting.
we have an alkene.
Yeah, why not?
Okay.
So which family is this?
The one on the right is an ethyl.
No, which family of compounds is this compound belong?
Acid anhydride.
This is an acid anhydride because you've got 2 carboxylic acid units condensed together. Okay, good. So we have to look at both carboxylic acid portions. This carboxylic acid, and there is another one. This is an asymmetrical unsymmetrical anhydride. Okay, so we have to figure out both of the names and then decide alphabetically which one comes first. Isn't that right?
Yep.
What would we call the orange carboxylic acid? So pretend it's a carboxylic acid, what would you call it? So where are we numbering from? 1,
Right, yeah.
2, 3, 4, 5, 6. Okay. So what are you going to call it? Hex?
Z.
Good. Z, because there's a stereochemistry shown.
Hex.
Hex, but where is the ene?
Hex-free enoic acid.
3-ene-oic acid. Isn't that right?
Mm-hmm.
What an acid one. What about the blue one? What would we call the blue one?
Propanoic acid.
So, which one do you think will come first? Alphabetically. Z, no, good. Not Z, you're going to count the H with the P.
Yep.
Do you agree? Separate word though. This word is separate from there.
Uh-huh.
And then followed by a third word, which one?
Anhydride.
Because it's an anhydride. So again, each part is explaining each of the acid portions from that are coming together to create that anhydride. Does that make sense? In alphabetical order. What if, I'm just assuming, I mean, okay, just an assumption, guys. What if this were butanoic instead? So instead of propanoic, what if it were butanoic?
So it would be butanoic, Z-free, Z-hex-free, enoic.
So that's what I wanted to actually illustrate. You're right, we switch it, and you're right, absolutely, Carter, that this whole thing comes here, but the Z stays there because the Z is about that ene, so Z has to stay with the correct ene. So then it would become butanoic space, Z-hex-3 enoic space, anhydride, because Z can't leave this name and go anywhere else. So Z has to stay wherever it belongs.
It's sort of like tert-butyl.
Yeah, it's just like the prefix tertiary, you mean?
Yeah,
Absolutely.
the prefix tert-butyl.
Okay, next one. What do you think we should call that? Oh, that one is a little tricky because it's really known by its common name, not by its IUPAC name.
Benzonitrile.
So what would it be?
Benzonitrile.
The common name for anhydride, for nitriles, using that symbol. So what is this guy? What is that?
Benzoic acid.
So what will this be? So that carbon is the same as this carbon. So benzoic acid becomes, take the ick away, becomes benzonitrile. Yeah, I've never heard anybody calling it anything but benzonitrile, so we should be used to it. Okay, what about the next one? Can someone tell me what would you call the next one? The last one on that page.
2,2-dimethyl propanoic anhydride.
Do you all agree? 2,2-dimethyl propanoic anhydride, because it's a symmetrical anhydride, so you just want to give one oic part.
Do we use the butyl?
You could, but then how do you name the acid with the T-butyl part in it? Can you name this carboxylic acid? Basically, the carboxylic acid is this. Right? So that doesn't work very well. But IUPAC, we could call it 2,2-dimethyl propanoic acid, hence 2,2-dimethyl propanoic anhydride. Is everybody okay? There's of course more examples. Let's do a few more and then we'll go on to the next thing on the list. There is, I think I've given you a lot of examples here. Maybe let's just try a couple more. I think the key for this is on Canvas. Could you please let me know if it's not on Canvas? But yeah. Which one?
The acid halide.
Okay, start with that. What would we call it? I'm going to take a few and write them on the board because I don't think we can go over all of them together, but there's quite a few seem interesting on the list. Yeah, that's a good question, right? Let's make it interesting then. How about let's name these. These are all from the list. You don't have to draw them, you just have to find it.
passing around.
You don't have to write these, guys. Please don't spend time writing something that's already been written for you. Find it and just name those.
Can we also write names on the board?
Yes.
Okay.
Let's make that clearer.
Mine?
Yeah. So especially when it comes to stereochemistry, make sure your drawing leaves no room for ambiguity. Make sure it's cis, I get that. But make it extremely clear.
You forgot stereochemistry.
Oh, you're right.
Have you heard of wedges and dashes?
reaction, of course, that's easier to do, but what you were doing earlier for cyclopentane, that would have worked,
Okay.
except make sure they are all straight, because one of them was like a little bit at an angle. What you had drawn earlier, this is totally good, there's nothing wrong. But what you had drawn earlier would have also worked for cyclopentane. What you had done was you had one that was going up, great. But your other one was kinda at an angle.
Oh, okay, I think
So that becomes, so you have to be very careful. If you wanna use this style, straight up or straight down. No angles. Does that make sense? But wedges and dashes is just easier. That's all I was trying to say there.
I was just thinking if it's, you have to get clear.
Alpha cyclobutene.
You have to get clear from the street?
What do you mean? You mean RS? Is that what you mean,
Yeah,
RS?
that's why I didn't wanna put the. wedges
Totally,
dashes.
I totally get it, I totally get it, because, you could have also drawn it with wedges.
Okay, so it's
Right?
just saying, okay, no.
So, what the point you're making though, Camilla, is a very good point. That wedges and dashes now bring us in the RS territory, not just cis strands. These are both cis, but they are not the same as each other, they are stereoisomers of each other. They are enantiomers of each other. So you're right that wedges and dashes bring us in the RS territory. So therefore you were trying to do the other drawing, and that is great. Absolutely, I'm willing to take any of those answers.
So would the right answer just be that plus or minus?
Or just choose one,
Okay.
who cares? They are cis. If you decide to do it this way, just make sure your bonds are very clearly, without any ambiguity, going up or going down, or whatever the case might be. That's the only thing I was trying to clarify over there. Absolutely. Now, if it was cyclohexane though, then of course chair form with cis and trans, which takes care of everything else. Yeah. Okay, more. Come on, guys. There's lots more.
Ethyl cyclobutene. Ethyl cyclobutene. Cyclobutene. 1, 2. Carboxylate.
Is that an N or an A?
A.
Otherwise,
Make it bigger, Carter. Could you make it bigger?
Oh, make the structure bigger?
Yeah.
Oh, that's right. Like that?
Yes.
Jane, when you have 4, so you have like trimethyl, butymethyl, it's a quad methyl.
Thank you.
This one, because you have 2 methyls here and 2 methyls here.
what happened?
What is after tri?
Tetra.
Tetramethyl.
Tetra.
I would want to say quad methyl, but
Yeah, tetra. The funny thing is, nobody there answered you all. Did you all forget what is for?
Tetra.
But tetra doesn't count, right?
Z and
Tetra doesn't count. T,
No, no, no.
yeah, no.
Yeah, only iso and cyclo.
Yeah.
Prop, are you sure? Prop is 3.
I was just randomly.
I see people are strategically avoiding that one. That is,
Wait, that one? I'm gonna try and do that.
okay, very cool.
And then CH2, C. Um,
Mark, is that your phone?
No, what phone?
Whose phone is?
Somebody left their phone?
Oh, okay, I'm sorry. Okay.
I was gonna say dibs, but.
It said somebody forgot.
this, yeah.
Okay. Why am I having a hard time remembering what it is? 1, 2, 3, 4.
It's an app.
Where's your head, Steve?
Oh, I was just building off of it, so I was like.
Okay, but then where's epoxy supposed to be?
Oh, I'm over.
I think it's S because we're going counterclockwise.
But H must be going away from me, so I just flipped it.
But
Dash, is that hard?
I don't know. I'm
So where's
stressing.
priority one? Okay, why?
H is on a dash
So you
too.
wanna switch the two?
No, why? Why do you need to switch the two?
Why would you?
Don't we want the lowest priority on a dash? And it's already
Yes.
on a dash, so we don't have to do anything.
Why swap it then?
You're right. I knew that.
I guess it was one of those things from like 6 months ago.
So, also count your carbons. So where is carbon one?
Frick.
Where is carbon one?
This would be carbon one,
No, yeah, so where is that in the structure? Yeah,
right here.
Oh wait,
3,
so
No,
where
it's-
is methyl?
4,
it would be at the carboxyl.
6. Methyl would be 3. So this would be 3.
Yes. 3-methyl, and then what's the longest chain?
6.
No. You counting an extra carbon?
Am I?
Here,
I'm having a stroke. 1, 2. It's actually connected to this one.
Yes, 3,
3,
4.
4. I am. This would be 4.
You see it?
This would be 5. Yeah. There we go. I'm just gonna. Oh, I don't want to erase that.
Yes.
Oh, why? My brain is not liking this one at
No,
all.
but you're still doing a good job. Okay? Cool.
it's a carboxylic acid. So
Before you just got ketone?
No, nitrite. Oh, ketone, yes, ketone.
So it'd be like a ketone, right?
Yeah. So then what would you call it then?
Does that mean that was like lower priority than, like in, the halide is acid, like in naming, because she wasn't naming as an acid yet?
But that's not an acid The chlorine is not on the C double bond O. The chlorine is one carbon away.
Oh.
Otherwise it would be an acetic acid. Yeah?
I gotta protect myself.
Chlorine is not on the C double bond O. Dye meaning out of charge?
Yeah.
Okay. But you're right, that's not an acid halide.
Okay.
Because the chlorine is one carbon away.
So you just have to install
Pentane.
The choice is between ketone or nitrile. Should it be a ketone or a nitrile? I do think ketone takes priority over nitrile. Nitriles are pretty low in priority. Is Dash just taking over today?
As usual. As usual.
Yeah.
I think his name here is wrong.
Go for it, fix it. I gave up on that one.
Oh, you're right. Yeah, that's right.
Free methyl pentane.
He just got tired of waiting for Dash.
Oh, sorry.
No, you're good.
I'm not sure if that's right either. Free S, free methyl pentane benzoate. It's an ester, so.
Should the ketone take priority over the? You said the ketone takes priority, right?
Yeah, nitriles are very low in priority. Very low. I should, is somebody on Canvas? Can somebody can you access Canvas? I think I already attached a document that says something about priorities of different groups. Yeah, and for naming, I think that would be relevant now that we've learned to name almost all families. Why three? Oh, okay, so see, here's the thing. If nitrile is not the parent, then why are we counting nitrile as carbon 1? But it's not the parent, that's if it's a parent. It's not
Oh,
the
that's
highest priority
right.
thing. It's a cyano group, right? You're calling it cyano.
Nitrile is not,
Yeah,
is
but-
not the parent.
I think.
But do we,
Otherwise, you'll end up
It would be
counting
a
that
ketone
carbon
of a
twice.
nitrile, the
If
nitrile
you
would just be
include it in the parent and include it in cyano, then that carbon gets counted twice.
I think that's what you just said.
but do we count the cyanocarbon?
No, because it is not the part of the parent.
Okay,
But we should number it
Just-
that way also.
just to clarify.
What's your parent there, Carter?
Oh, a ketone.
Okay.
A ketone.
Guys, let's go on. It's already 2 o'clock.
Oh,
So
shit.
let's go through the names, make sure we agree and or not. If there are questions, I'm hoping that you would ask. Do you all agree? So,
Actually, I had a question about that.
oh, I do too.
Because that.
Now that I'm seeing it.
The lead and alkyl.
Exactly. So no, this will not be correct. The alcohol portion comes first. This is the alcohol portion, the one that's bonded, single bonded is the alcohol portion. That comes first as the alkyl, cyclopentyl. That's your alcohol portion. The acid portion is this part, is the acid portion. So this is going to be Z, is it Z? Yeah, okay, Z. 1, 2, 3, 4 methyl, but then who should come first? 2-chloro, right?
Yeah.
2-chloro, 4-methyl, and then what? 1, 2, 3, 4, 5, pent, 1, 2, 2-ene, wait. Yeah, that will not be correct, Carter.
Okay, thank
The
you.
alcohol portion comes first,
Oh.
carboxylic acid portion comes next.
Okay.
Is this looking okay, everybody? Is that a yes from everyone?
Yeah.
Cool. Let's look at the next one. Again in ester. Ooh, ester, yes. So ethyl, good. And then S, 1, 2, 3, R, but that's okay. S, 1, 2, 3, 4, hydroxy, 3 oxo, pentanoate. 1, 2, 3, 4, 5. Perfect, good. We already talked about this. Is this okay for everybody? That's again an ester, ethyl, good. Cyclobute, 2-ene, 1, 2, yes, and carboxylate, good.
Good luck.
Like, where's the comma? Can't even see the comma. Okay, if you had to simplify it, wouldn't it be? So there was some confusion about that. What is that supposed to be? That's a CH2, COOPH.
Yep.
And then there, of course, right?
Yeah.
So now the alcohol, so no, this is not, this one is not going to be. So phenyl, the alcohol
Okay.
part comes first.
Oh, yeah, you
And
were
then
right,
the
Dash.
acid, 1, 2, 3, 4,
You were
5.
right.
S3-methyl pentanoate, good.
Okay.
Okay, amide, NN, 1, 2, 3, 4, 3, 4 tetramethyl pentanamide. Okay, looks good. That's really a ketone. Did you find that document in Amayas?
Yeah, it's on
It's
there.
which module?
It's
The first module?
the course information module.
So guys, on Canvas in the course information module, I think I've uploaded a document that gives you priority orders for different families of compounds, in case you were wondering. So am I right in that document that nitriles are pretty low in priority? Am I correct? Lower than ketones? That's okay. Now we're all going to stare at Amayas. Just kidding. Okay, we'll come back to that. We'll come back to that. Is it? Did you find it? Benzyl, good. And then 4 amino, 1, 2, 3, 4 amino, 3, 1, 2, 3 cyano, 2 hydroxy, 5 methyl, 1, 2, 3, 4, 5, 6 hexanoate. Looks great. This is correct as well. I was looking at it earlier. So 1, 2, 3, 4, 5, 6. That's a Z, 3 ethoxy, and then dibenzyl.
I forgot to change it from pent to bute. After changing.
But I'm still waiting for the verdict. What does it say?
It's like right in the middle.
But above a ketone, below the ketone. When it comes to ketone and cyano, who's got the higher priority? May I?
It's above.
Yeah, it's above.
It's above?
We have most days, so.
Ah, then I'm remembering it wrong. Where? Oh, you're right. It is way above ketones. So then we should call it a nitrile.
Yeah. So
So,
my name is wrong.
that's okay, that's okay.
We were
Guys,
trying,
may I have you guys, yeah. So yes, I was wrong in my earlier assessment that cyano is lower in priority, nitrile is lower in priority than a ketone. That's actually not correct. That has a higher priority than the ketone. So how do we change this name, making that the parent?
Start with the CO.
So now our numbering has to change. Where's carbon 1?
On the nitrile. So it would be 4-chloro, 3-oxo, pentane nitrile. Yeah. Okay.
Exactly. Exactly, yeah. I thought ketones had a higher priority.
Samira,
Yes,
would that, so that ethyl cyclo 2
Yes.
is with, why would the, oxygen be on that carbon not? Cause wouldn't you count the C for the?
when you have a carboxylic acid, I think that's what you're thinking. Tell me if that's what you're thinking. Are you thinking that the double bond should be there?
Yeah.
Okay. So when it comes to ring, whatever the ring is, and you have a carboxylic acid, counting starts from here, not there. Starts from the ring, and then whichever direction. So same thing, by the way, same thing for aldehydes. When you have an aldehyde of a ring, you're not starting from the carbon of the aldehyde, you're starting from the carbon of the ring. That is why these are called cycloalkane or alkene or alkyne, whatever, carboxylic acids. They're not called cyclopentanoic acid, they're called cyclopentane carboxylic acid. So the point I'm trying to make is this carbon is accounted for here. It's not counted there. So the numbering actually is starting from the ring, which means that if you're looking at this one, where is carbon 1? It's not that carbon, it's this carbon right here. So hence 2. Make sense?
Yeah.
Uh-huh.
That's going to be the case for carboxylic acids and aldehydes. You'll see that happening. Anything else, guys? Cool, that was fun, right?
A little wacky, yeah.
Yes, that's why fun, otherwise it's boring. Okay, we still have a few more minutes, so let's at least talk about nitriles, because nitriles, most of it we've already finished. There's a little bit of new stuff that we can then address on Wednesday, and hope to finish both chapters 20 and 21. We'll see how it goes, but I think we can finish both on Wednesday. But so let's start with nitriles. I'm trying to be as consistent as possible with the book you guys are using, because they're doing nitriles in chapter 20, so let's do that. Now, what are the common ways for making nitriles? Something that you've seen already. Alkyl halides can do SN2 reaction with cyanide ions, right?
Yep.
It is SN2 though, because that's a good nucleophile. So SN2 reaction, not SN1. So of course, whatever goes with SN2 that we've already learned a lot, everything applies here. Another thing we saw was converting aldehydes and ketones into cyanohydrins. If you remember, do you guys remember that? Of course, that doesn't give us just a nitrile, it gives us a hydroxynitrile. But you guys remember that, okay? There is one method of making nitriles that we have not seen yet, and we're not getting into the details of it. It is from a primary amide. Primary amides can create nitriles. Can you tell me what kind of a reaction would it be for the primary amides to become nitriles?
Dehydration.
It's a dehydration reaction. If you just look at the difference between the primary amide and nitrile, notice the difference is H2O.
Yep.
H2O is gone. It's a dehydration reaction, and this reaction is done most commonly by using something called thionyl chloride, which we've seen before for a different purpose. But yes, thionyl chloride causes loss of water to create nitriles from a primary amide. We are not looking into mechanism or anything for that. Okay. Now, as far as reactions of amides are concerned, and I'm just going to list them here, and then we'll go into the details on Wednesday, and a couple of them we'll write mechanisms for as well. One reaction we've already seen for nitriles is they can be hydrolyzed. They can either be hydrolyzed by heating in an acidic environment, or they can also be hydrolyzed in a basic environment, but then you have to protonate it again separately. You have to do a separate step of bringing the proton back, and this converts nitriles into carboxylic acids. We will go over the mechanism of this reaction on Wednesday. Another reaction we've also seen already with nitriles is you can use La lithium aluminum hydride, which reduces the C triple bond N into a primary amine. We are not looking into that mechanism, but yes, we've seen the reaction before. That's a 4. Sorry, that's a 4. And one other reaction whose mechanism we will go over on Wednesday is their reaction with Grignard's reagents. Yes, nitriles also react with one equivalent of Grignard followed by acid workup, and this creates a ketone. We will go over its mechanism on Wednesday as well. So let's stop here. We will go over those reactions again on Wednesday, look at some of the mechanisms, and then get into the reaction syntheses and reactions of other acid derivative families.
Okay.